Good morning, everyone. Today we are going to continue with the unit number 3, that is pillars of embedded IoT and physical devices. Okay. So in the previous sessions, we have seen about the device and connect from the DCM. In that we have seen that is connect, that is pervasive network. We have seen the wired and wireless communication. We have seen the field bus network, and there are 8 types for that field bus. Okay, so we have seen that 3-layer structure for the field bus, and we have seen the 9 layers. That 9 layers are as per the industrial concern. Then we have seen the wireless communication for the connect. That is, in that wireless connection, we have seen the short range and the long range networks. We have seen the different examples with the wireless networks, or we have seen the wireless communication mechanisms. In today's sessions, we are going to see that what are the wireless communication mechanisms are there. And before that, we have seen some multiple accesses, like we have seen the FDMA, TDMA, code division multiple access. Okay. In now today's session, we are going to continue with the same network. That is, we are going to see the frequency division multiplexing. Then we are going to see some Adhoc sensors networks, software defined radio. That is, these are the wireless communication mechanisms. Like, then we are going to see one video with the satellite IoT. That what is satellite IoT is there. Then we are going to see the last part of this DCM, that is manage. That is to create the business values. Okay. So now we are going to start with the orthogonal frequency division multiplexing. That is, in that first we are going to see the FDM. We know that what is frequency division multiplexing. In that we have seen that in the last session. That is, we are going to divide the bandwidth into that users. We are going to divide the frequency of between the users. Here you can see the subscriber. Okay, subcarriers are there, and you can see there are multiple users are there here. That is user 1, user 2, user 3 up to user n. And here you can see that these are the frequencies we are divided with the, or the bandwidth we are divided with the number of users. That specific bandwidth is allocated to specific users. Okay, so here you can see these are the subcarriers. This is the frequency here. In that FTM, it divides the bandwidths into many subcarriers. So, and that because of that, it allows multiple users to get the access of that system simultaneously. Okay. Then now here you can see the different users are there. We have seen that bandwidth is distributed to the different users, and here you can see that the data, different users data gets transmits at different subcarriers. So between that subcarriers there exists a guard band. Here you can see the guard band between the different users or different transmissions. So this guard band requires to avoid the interference between the users. There is no interference between this user 1 and user 2 because of this guard band. Okay. Then multi-carrier FDM. So in multi-carrier FDM, the data of a single user can be split into multiple substreams. So the data of that single users is distributed among the different users, or that stream of data is transmitted from the user 1 to multiple user in the form of serial to parallel conversion. Here you can see that the data is transmitted. Here see the data that user 1 is having this serial numbers, and this data is transmitted over the number of users, number of subscribers are there. That means multi-carrier FDM. That is, single data is carried to the multiple users. Then OFDM, that is orthogonal frequency division multiplexing. So in that subcarriers are orthogonal. Orthogonal means here we are going to see that orthogonal which allows subcarriers to overlap. Here you can see the subcarriers are overlap with each others, and hence that saves the bandwidth and achieving higher data rate. If we are going to share the bandwidth with each others, then because of that it allows to save the bandwidth and achieve the higher data rate. If we are going to share the bandwidth with the users, because of that it allows us to achieve the higher data rate. That means the data transmission rate is higher because of the orthogonal. Okay, that the subscribers or that bandwidth is shared between the users. Then now we are going to see or in the last session also we have seen the different wireless communication mechanisms like ad hoc sensor networks, SDR is there, CR is there. Okay, so first again we are going to see these wireless communication mechanisms. That first one is your ad hoc sensor network. So we have seen that the ad hoc network provides connectivity to two or more mobile devices for a temporary basis. For temporary basis, it provides a connectivity between these devices. So without having or without engaging any vast infrastructure with that devices, it provides a connectivity between that devices. So ad hoc network also requires very less administration, low cost, and can be deployed in a remote geographical locations. And it requires a minimal setup. That means it requires less administration and having less cost or low cost for setup for setuping this network. Okay, and that ad hoc network is based on or it can be integrated to a larger network like internet. In the last session we also discussed about this ad hoc sensor networks, that that network can be integrated to a larger networks like internet to increase the coverage of data. Because of that we are having the remote geographical locations, or we are going to share the data with the different locations, or we can access the data from the different locations. Because of that ad hoc network is based on the or integrated to a larger network. So here you can see it can be or it's said to be a emergency or temporary network. This kind of network is a emergency or a temporary network is there. The very first sentence we have said, I have said that it provides a connectivity between the two or more number of devices for a temporary basis. Okay, that means this network is a temporary network for the communication. Here you can see the example of ad hoc sensor network, that we are having one vehicle and we are having one temporary house is there, and that we can see that we are going to access the some data from that network. Here you can see that we have created one network. That means we are having temporary equipment with that house, and we are going to access that data from that house, like your vehicle is carrying the communication. That means your video communication is there. Okay, so we are going to access the data from that devices in the form of any songs are there, like from the waves we are going to access the data. Okay, then next communication mechanism is your software defined radio, that is SDR. So that SDR is a full-fledged software implementation of any hardware component like amplifier, filters, mixers, modulators, or demodulators. So that means that SDR using a software to replace hardware. That means that software implementation, or that it is a software implementation of that hardwares. That hardwares can be your amplifier, filters, mixers, modulators, or demodulators. You can see that that hardware is still needed for radio frequency. That means for the front end to convert that analog to digital and signals, and to convert the digital to analog converter is there. So we are having ADC and DS, that is analog to digital converter and digital to analog converter in the SDR. So we have seen that the SDR usually contains a personal computer. Okay, and we are having analog to digital converters like a sound card is there, and at the front end to access its functionalities. Okay, so SDR also provides a different way to define the parameters like the radio frequency. We have seen that it needs the RF radio frequency, and modulation types are there, waveforms are there. Okay, so the advantage of this SDR is like we can receive many signals with single piece of hardware. Okay, so we are going to see the example for that. Here you can see the hardware radio receivers. Okay, here you can see that signal. We are going to receive the signal with the amplifier. The amplifier contains the signal. Okay, and we are having the filter and amplifier to make sure the signal uses correct amplitude. Okay, and we are having the demodulator. That means we are going to get the uh, another form of signal here. Here, see there, this is the SDR here. With the antenna, we are going to receive the signal at the amplifier, and we are having the analog to digital converter. Why we are having this converter? Because we know that at the front end we are having the personal computer or the device through that we are going to access this data, and we know that personal computers can understand only the digital format of information, or it can understand only the digital signals, so that we are going to convert that analog signals into the digital form. Okay, so after conversion of this form, that computer understand this information and again passes this information to that device, so that it is having digital to analog converter. Now we are having the digital information, and we have to convert the digital information into this analog form. That means we are going to convert the digital signals into analog, and we are going to pass it to the amplifier. Okay, so that this is the processing. That means we are going to process the input, and we are going to pass the output to the device. Okay, that is all about the software defined radio. Then see this SDR, it is the result of the evolutionary process from the purely hardware based equipments to fully software based equipments. That we have seen that we are having the hardware, and we are going to implement that hardware to the software. Okay, like we have seen the different functions for that, like we are having different modes, different applications, like we are going to transmit the frequencies between the devices, and then we are having the modulation type. We are having the modulator, demodulator. We are having the radio frequencies. Okay, that can be configured through the softwares. That means that software defined refers to the use of software processing within the radio system or device to implement operating function. That means we are going to operate the devices through the software. Okay, that is all about software defined radio. That means we are going to operate that hardwares through the software. Then next part is your cognitive radio, that is CR. So in the last session also we have discussed about this CR. It is a form of wireless communication. Okay, so this is a form of wireless communication in which, or that transceiver, that means radio, to detect which spectrum or which communication channel is in use. So for that we are using this cognitive radio. Okay, so when any communication is required, the occupied spectrum or that communication channel is not disturbed. Okay, whenever any communication is required for the user, that means that already existing channel is not disturbed, and the vacant channel is provided for the communication. Okay, so now your these are the wireless communication mechanisms. Okay, now we are going to see about the satellite IoT. So that satellite IoT or the communication satellite, that means ComSat. You know that, if you heard about this, what is ComSat? It is a specialized transponder in the space that transfers radio waves from one location to another location on the earth. So this is also called as a bent pipe. Okay, so we know that the satellite industry is working together with the space organization and some telecommunication industries uh, to get the data from the satellites. Okay, so that satellite technology can be used in implementation of IoT based application with a superior communication in the remote access, or from the remote areas. Okay, so that satellites can be deployed in varied orbits, like that orbits are surrounded on the surrounding the earth, like we are having the geostationary earth orbit, medium earth orbit, that is GPS. We are having the low earth orbit or elliptical orbits. So this kind of orbits we are having. Okay, so there are some major challenges are there with the satellite communication, like speed and cost. Okay, so there is one video. Yeah, any problem? Okay, so there is one video regarding with the satellite IoT. Okay, so now I'm going to play that video. You have to watch that. Okay, and tell me that your that voice of that video is, or that video is audible to you or not. Okay, so this is the satellite video regarding the satellite communication. Okay, now listen carefully. Satellite communication. Yeah. Okay, so this are you able to listen that video? Yes.
Yes, sir.
Yeah. Okay.
So,
Okay, now listen this video.
A satellite is an artificial body placed in an orbit around the Earth or another planet. The communication satellites relay around the world telephone and fax messages, television programs, radio signals, and so on. Principle of satellite communication. The process of communication begins at an Earth station. The Earth station is an installation designed to transmit and receive signals from a satellite in orbit around the Earth. Earth stations send information in the form of high-powered, high-frequency signals to satellites that receive and retransmit the signals back to Earth. These retransmitted signals are then received by other Earth stations in the coverage area of the satellite. The area which receives the signal from the satellite is known as the satellite's footprint. The transmission system from the Earth station to the satellite is called the uplink, and the transmission system from the satellite to the Earth station is called the downlink. Here you have the schematic representation of the principle of satellite communication. To avoid confusion, the uplink and downlink frequencies are kept different. Before designing a satellite communication system, we must choose the orbit in which the satellite is to be placed. Orbits are of three types, namely geostationary orbit or geosynchronous orbit, polar circular orbit, and inclined highly elliptical orbit. Geostationary or geosynchronous orbit. In this type of orbit, the satellite takes 24 hours to circle once around the Earth. Since the period of revolution of the satellite is equal to the period of rotation of the Earth, the satellite appears to be stationary in the sky. For this reason, this 35,900 kilometers high equatorial orbit is called a geostationary orbit. The geostationary orbit is also known as Clarke's orbit. This is in honor of Arthur C. Clarke, the man who first suggested in 1945 that satellites in geosynchronous orbits could be used for communication purposes. Entire Earth can be linked or covered by the communication network if three geostationary satellites are placed at the vertices of an equilateral triangle. Each of the satellites covers 1/3 of the globe. Polar circular orbit. This type of orbit is placed 1,000 kilometers above the Earth's surface. It passes over the poles. The angle of inclination of this orbit is 90 degrees. Scans the whole Earth every 12 hours. Satellites used for weather monitoring are launched into a polar orbit. Inclined highly elliptical orbit. It is used for establishing communication with regions at high latitudes. The angle of inclination is equal to 63 degrees.
Yes, everybody understood this video. It's regarding the satellite IoT, that how the satellites are placed with their orbits, the geostationary orbits. In that they have told that for the weather forecasting, they are placing a satellite with the polar orbit at the 90-degree. Okay. Yes, everybody understood. Have you understood that satellite IoT? What happened? So, am I audible to everyone?
Yes, sir.
Yeah, have you understood that video? Have you understood or not? Yes, what happened? व्हिडिओ समजली की नाही सर्वांना? Yes. Am I audible or not? Yes, Kote Ashwini.
Yes, sir.
Am I audible?
Yes, sir.
So have you understood that video?
Yes, sir.
Okay. Anyone? सर्वांना व्हिडिओ समजली आहे की नाही? So what is
Yes, sir.
uplink and what is downlink is there? Trans receiver is there. How satellites are going to communicate with the Earth orbits. Okay, so this is all about the satellite IoT, and there are different applications for satellite communications like weather forecasting, internet access is there, global positioning system, that is GPS is there, TV and radio broadcasting. Okay, these are the examples of satellite communication. Now we are going to see the next part, that is manage to create business values. Okay, so the business values of IoT comes from like knowing when and where to use the data values. Okay, so in the previous sections we have seen about how the data is gathered and communicated throughout the IoT systems through the device and to the connect. To the device we have seen that how the data is gathered, and it the connect, that connect means we are using that wired or wireless communication. That we have seen how that that this communication is happen between this IoT system. Okay, so now in this section we are going to see that how the data is managed and the information can be used to provide the opportunities in the business. Okay, so with the IoT and the analytics, it is possible to make business predictable. Predictable means here you can see the example like predict when that machinery would need maintenance. That means if you know that recommendation systems are there, prediction systems are there, that means we are going to predict with the IoT. Okay, so in case of we know that huge amount of data is gathered by the IoT based systems or the devices, and we know that not all the data is useful for the processing. Okay, from that some data is having the low values, or even some data is noisy data. Okay, so that means we have to avoid that such kind of data through the processing stages. Okay, so that means so that we need the high computing cloud based platforms we need to process that data or to convert the data into the useful information. That means we are going to remove the noisy data or the data having the low values. Okay, so this processing is important in view of value creation and the customer satisfaction. That means if we are going to pass the data with some low value data, or we are going to pass the we can say that noisy data to the customer, then the customer is not satisfied with, because that the customer is getting the unnecessary data with that. Okay, so we have to convert that data into the useful information. That means we have to remove the low value data and we have to remove the noisy data. Okay, so that we need that customer satisfaction. Okay, so that IoT helps to create the values in the industry. Okay, so that IoT based applications that can be linked to the existing platforms of like mobile operators are there, or multiple subscribers are there. Okay, Like we are having the different users that uses the smartphones, like in the smartphones they are running with the different operating systems are there. Okay, it means different platforms are there for the M2M applications. Okay, so there are different stakeholders are there that they are using the different platforms for accessing the different applications of IoT. Like if we are going to consider the examples, like ERP systems are there, CRM system, that is customer relationship management system is there, manufacturing monitoring is there in the industry. Okay, so this kind of applications or the GUIs are there. We can access this application through this kind of platforms. Okay, like smartphones, where we are going to consider the example as a smartphone, we are going to access this kind of application through these platforms. To access these applications, we are having some middlewares, or we are having some automation are there, some processing techniques are there. Okay, so this middleware or this processing techniques are like we have seen that SCADA system is there, PLC logics are there, RTU units are there, different kinds of systems are there, like field bus control is there, some distributed control systems are there at that middleware. Okay, so through that we are going to access this, or we are going to make happen the connection between the devices using some communication or gateway management or some protocols. We are going to communicate with the application, okay, or with these devices, or we are having some smart devices. That smart devices can be your sensors, embedded systems are there for the for sending and actuation purpose. Okay, so we are going to communicate with these devices through these middlewares or through some softwares, and we are going to use the applications at the front end, okay, to access this or to control these devices. Okay, so from that we are going to take the values that we need. Okay, so if you are going to consider the example of video analytics for the business to customer in case of retail environment, so here you can see that install equipments that use video cameras. If we are going to consider the video analytics, it uses the video cameras to detect the customer features like their age, their gender, and their customer moods. Okay, so based on this analysis, the software determines which ad to display to that customer. Okay, that means that you can say this kind of recommendation systems are there or prediction systems are there based on the users. If you are going to see that whenever we are searching on the net, that time if you are searching for the particular product, then next time that system is also recommending the same products or related products to that. Okay, so that in case of video analytics, if that software we are having, that it reads the features of that customers, okay, like gender, their age, and based on the customer's mood, they are going to determine or they are going to display some ads related to that customers needs. Okay, so these are the insights that can be used to boost the sales or to help the customer to find what they are looking for quicker and to test the attractiveness of different products. Okay, so this kind of softwares are there, so that we are going to manage the business values. Okay, so this is the third part of your, here you can see the example like snap scan is there. Okay, this is the service that detects the tire tread depth when a customer drives into a parking lot. Okay, so this kind of applications are available, or through that we are going to manage the business values. Okay, so in this way we have seen the device, connect, and now we have seen the manage. Okay, so there are two categories of IoT business values, like increase revenue is there and reduce cost is there. Okay, okay, in this way we have seen the that device, connect, and manage. Now the next point is our Raspberry Pi. Before that we are going to see the IoT physical devices and some endpoints are there. Okay, so we know that what is the IoT device is there. In the previous sections or in the previous chapters, we have seen that what is a thing, that thing or a device. Okay, so things means these different devices are there. In IoT based systems, to any object that has a unique identity or unique identifier is there, that has ability to sense data, okay, and exchange this data over the network, it is your IoT device or thing. Then that IoT devices can connect or to interact and send information about itself and surrounding over the network. These are the IoT devices. Okay, and based on this collected data, IoT system also provide actuation capabilities to the physical entities. We have also seen that what are the physical entities and what are the virtual entities are there. Okay, we know that means in short we know that what are the IoT physical devices. Okay, so we know that the different IoT based systems are there, like home automation system is there, industrial automation is there, vehicle automation, health monitoring systems. These are the examples of automation systems in case of IoT. And we have seen the different building blocks of IoT devices, like if we are going to talk about the IoT device, then the device must provide sensing or actuation, and communication and processing capability is must for that IoT devices. And we know that what is sensing is and what is actuation, what is communication, and what how we are going to analyze and process the data. Okay, the data is collected through the sensors. So this is all about your basic. There are three basic building blocks, like sensing or actuations, communication, and analysis and processing. Okay. Now your next point is your Raspberry Pi. Okay. So that in the very first study assignment, you have learned about the Raspberry Pi, but we will see what is that Raspberry Pi. Okay. So it is, you know that it is a mini computer having a size of a credit card. Okay, that kind of size is having that Raspberry Pi is a series of small single board computers that are developed in UK by the Raspberry Pi Foundation to promote the teaching of basic computer science in schools or in developing countries. Okay, so this is the motive at that time. Okay, when the Raspberry Pi Foundation developed this Raspberry Pi. Okay, so the functions like Raspberry Pi is like a normal computer does, and needs to connect it with the external input and output devices like mouse, keyboard, displays are there. Raspberry Pi runs on Linux-based operating system and has a dynamic support of Python. Okay, it also allows connection of sensors and actuators by the means of on board of general purpose input output pins. That means GPIO pins. If you have studied that Raspberry Pi assignment, you have seen that GPIO pins are there. Okay, so there are three latest versions are available in the market of that Raspberry Pi. Okay, here you can see the Raspberry Pi 3 model B. Here in that you can see that different components are there, like there are 40 pins are there for the extended GPIO. You know, if you have seen that diagrams or that tables, that dimensions is given, like dimensions for that kit. Then we are having different ports are there, different USB ports are there, LAN ports is there, composite video and audio output jack is there. Okay, CSI camera is there, different ports here you can see for the camera different ports are available, USB port is there, LAN port is there. Okay, then we are having the HDMI slot is there also. Here you can see the full size uh, HDMI is there, that is video output is there. Okay, then micro USB is there. Here you can see that micro USB power input is there. Then we are having the micro SD card slot is there. Okay, SD card we have seen that. Then we are having the Bluetooth for that onboard Bluetooth is there, Wi-Fi is there. Okay, so these are the components of that Raspberry Pi is there. Okay, so that means we are having the processor and RAM is there on that Raspberry Pi. That Raspberry Pi works on the ARM based processor. Okay, and processing power is 1.2 gigahertz, that is 64 quad core. Okay, ARM Cortex we have seen in the very first session that what is ARM Cortex. Okay, so basically it's having the 1 GB SD RAM is there. Okay, for that Raspberry Pi, and it's having some USB ports, like that Raspberry Pi comes with USB 2.0 port availability. Okay, and that Raspberry Pi 3 has a four. If we are talking about Raspberry Pi 3, it having four USB ports. Okay, USB hub is always good option whenever that number of USB ports requirement increases. Okay, then it also having the Ethernet ports. That means that the standard RJ45 Ethernet port is there. HDMI output is there. Here HDMI output is there. Okay. Then composite video support is available for that. Then we have seen that GPIO pins. There are 40 pins are there. That 40 pins are on board, out of which four types of general purpose input output pins are available. Okay, their SPI pins are there, I2C pins are there, serial RX and TX pins are there. So these are the 40 pins. Okay, so we know that different pins are there. That each GPIO pins is user configurable, and the number is associated with pin number. It is important in coding point of view. Okay, whenever you are going to code at that okay, at that time that pin number is must. Whenever you are going to mention that GPIO dot something, at that time that pin number is must. Okay, and that kit is having the different what we can say serial interfaces are there. Okay, it supports for that DSI, that is display serial interface supports, is available for the Raspberry Pi for LCD panel connection. Okay, and that camera interface is also available in the Raspberry Pi for camera module connection. Okay, then SD card slot is there. That SD card supports which can be used for additional storage requirements. Okay, and we can install that operating system on that SD card. Then power input is there, operating system support. We know we are, and then in the second assignment you have seen or you have learned that the different operating systems are available for the Raspberry Pi. Raspbian is one of them, Arc is there, Fedora is there, RaspBMC, OpenELC, different kinds of operating systems are available for the Raspberry Pi. Okay, so this is all about the Raspberry Pi, and we have also learned that how to install. There are different steps to install that operating system on the Raspberry Pi. Okay, different operating systems are available for the Raspberry Pi that you can install on that uh, SD card. Okay, so different hardware components are there for the Raspberry Pi. This is all about the Raspberry, and these are the hardware. You are also having this kind of tables. Okay, and there are another boards are like BeagleBone board is there, Banana Pi is there, Orange Pi, Ordroid is there, Arduino is there. Different kinds of boards are available. Okay, this is all about the Raspberry Pi. Okay, in today's session, we have seen about the Raspberry Pi, manage and FDM, and the different wireless communication mechanisms. Okay, so that's it for today's session. We will stop here. Okay, so everybody understood that about the Raspberry Pi, manage, FDM, or the satellite IoT. If anybody is having